chapter on here. Chapter 8. If I was to do this instead of following the book, I would do it kind of backwards from the way that he does it. Okay, but I'm not, so well, I guess we get to do it this way. Okay, so what 8.1's about is solving quadratic equations. Okay, 8.2 is on completing the square, which we don't cover, but it is covered in 95. Okay, and I guess maybe that's why they do it. It's not a very good technique for solving equations. It doesn't really have. It's just not very useful. So it's probably good that they don't actually include it in there. And then 8.3 is actually the best way to solve quadratic equations because it gives you solutions to every single one. All right. So, what is a quadratic? First of all, what are they even talking about? So, a quadratic is something that looks like this, which is like for us, we knew as a trinomial. So anything that has an x squared is considered to be a quadratic. All right, so if it has an x squared in it, then it's considered to be a quadratic. So I got like this one here is a trinomial. All right, this one here would be like a binomial and a binomial. All right, so we've dealt with those, but not kind of like this. This is kind of a different way of looking at it. So these are going to be equations versus what we've done so far is just work with these things as expressions, okay, and factor them. So now we're going to treat them as equations and solve them. Okay, so this 8.1 section talks about using what is called the square root property, which again is okay if the quadratic is in a certain form that you can actually use it, right, which is pretty darn rare. But let's take a look at some, all right, and we'll start out with some pretty simple ones and then work our way. Okay, so we're going to solve, all right, using the square root property. So if we have x squared equals 36, all right, so obviously what we would do there is do the opposite of a square, which we just got done doing a whole bunch of, the last couple of weeks anyway. What's the opposite or the inverse of a square? We just did a whole bunch of them.
Square root.
Yeah, square root, right? I mean, we just did a whole bunch of those guys. Okay. And when we first talked about them, I remember I said, well, there's a difference between a principal square root and a square root, okay? So a principal square root is just 6 in this case, okay? Because square root of 36 is 6. But when we're solving them, we're not necessarily looking at the principal square root. We're looking at values of x. They're going to give us 36 when I square them. All right, so this principal square root only gives us half of those values of x. It gives us 36 when squared. So obviously 6 squared is the answer, but so is -6, because it also gives us 36. So now we're going to say that x equals plus or minus 6 when we solve these using this property. We're going to get a plus or minus 6 there.
So we just answer, we give the answer in plus minus 6?
Yes, when, yeah, there could be a possibility, probably not, where you're not going to, not in this case. There will be some where you're just going to have one answer. Okay. So,
if it was negative 36, then you'd know it would be, I know you would.
all right, so let's say we have a 3 out in front. I don't know where this thing is dying out, or I don't know what it's doing here. 3x squared equals 27. Okay, so now what I want to do is treat it like it would a normal equation, right? If we treated this as an x, what are we going to do to both sides first? Yeah, so we're going to do the exact same thing. Okay, nothing really changes there. So we're going to get x squared equals 9. So then we square root that. And then what are we going to get for an answer? Yeah, but not just 3, right? You're going to get plus or minus 3, because it could be a negative 2. Okay, here we go. So then we're going to square root, and x gives us plus or minus 3. Okay. So really not much different there, you're just square rooting. Same idea. Then we can have one like this. Here, let's do one like this. Okay. So now we have an equation. So we should treat it just like we did if it was an x. All right, so what are we going to do first? Yeah, add the 8, right? And then?
Divide both sides by 3.
Absolutely. So then we're going to square root. And what do we get?
X equals
Plus minus 4. Yep. This is all using this square root property thing. Okay. Okay, so let's try this. All right, see what happens on this one. You say, well, it's not any different. Well, we'll see. So then what do we do on this one first? Add 5, right? And then? So x squared is equal to, now here's where something's a little different. Okay? So, one of the things, and we talked about this a little bit in mathematics, okay, right here there's 2 answers to this. Okay? One of the things we could say, well, in a practical sense, all right, if you were doing something, you know, in construction or whatever, in a practical real world situation, you'd probably say, okay, now I need to square root this. Okay, so then in my calculator, I'm going to take the square root of 7.5, find out what that is, and it's going to give me a decimal. All right, and I'll go plus or minus in front of it, call it good. 7.5, so that's going to be 2 something. I'm not sure what it is. Okay, but that's, in a practical sense, that's what you would do. Okay, but that just gives you a decimal approximation. In some cases, that's okay. I mean, maybe that's all you're looking for. All right. Ooh, it's a little thick. If we need an exact answer, okay, then when we square root this, the plus or minus is going to come out on the outside, okay, and I get this thing on the inside, all right? Now, we know, right, that that is the same as this, and we also know, can we have a radical in the bottom of can we have a radical in the bottom of a fraction? No. So what do we got to do to get rid of that? Multiply by that radical. Yep, good job. Okay, so then we're going to get 30 on the top. Okay, and 2 on the bottom. We can't do anything with the 30, so that's the answer. So, but plus or minus square root of 30 over 2 isn't, you're not going to find that on a ruler, right? I mean, it just isn't there. You're not going to find it on anything that measures stuff. It isn't there. Okay. Whereas you might 2 point something, you probably aren't going to see that either, but at least you get a better approximation for what the heck it is. All right, so I think a lot of times when you're doing this, it kind of depends on the situation, obviously. I think they're going to ask you for exact answers, all right, rather than decimal answers unless they specify. So you're going to have to take this route here in these certain problems. Okay. So let's try another one kind of like that. So just so we get to see what that looks like. Okay, so here again, obviously you're telling me you know how to do this. Oops, not yet. Getting excited there. 4. Okay, then I'm going to divide by 3. All right, you got all that part figured out. Okay, so now we square root. But in this case, we can do some of this because we know what the square root of 4 is. But we still got the square root of 3 on the bottom that we can't have. And Josiah says, I got to multiply by the square root of 3 because that's what he told me last time. And boom, there it is. Don't forget to put the plus or minus there. Okay. But again, in a practical sense, that wouldn't do us much good. We would, well, how are we going to figure out what that is on a ruler or anything? Okay, so, but this is how they're going to want you to do it. Questions on what we've done so far with these? We could have some also like this. All right, and in this case, the square is on the outside of these, so we can't subtract 3 because it's inside parentheses like that, so you can't do it. All right, so then you just square root right away. And what happens is that the square root, okay, undoes this square, so they kind of cancel each other out, and we're left with this. I'm going to put my plus or minus out in front there. Then I'm going to subtract 3 to get this x by itself, and I'm left with something that looks like this. Now I should reduce this down, okay? Because I can, so I should probably reduce that down. And we've done it, you guys are pretty good at this. So square root of 4 is 2, so that 2 comes out. There we go.
Is it plus or minus 2 square root of 2, or is it negative plus or minus 6 square root of 2? Would you add them or would you multiply them when you figure it out?
Oh.
We move the 3 over, is that?
So the 3 is being added or subtracted to that, right?
Okay.
So that 2, the square root of 4, pops out in front. It's not multiplying to that guy. So when you have a situation like this, okay, and it's set equal to some number, 10 or whatever, in this case you always have to square root first because you can't subtract the number that's inside there. Okay, even if there was a number in front here, okay, you got to do square root first. You just have to. So you can get rid of that square. And I think this isn't going to cause you a whole lot of problems. It's just a lot of times people will forget about the plus or minus. Okay. Let's see. I'm looking at these to see if there's anything on here that we didn't really go over. Solve these by first. Did I give any on page 540 that were between 31 and 40? Check your syllabus thing and see if I did any of those.
31 and 40?
Yeah. Did I give anything? No? Okay, that was smart of me. How about after 41? Did I have any of those?
41 to 48.
Okay, let me do a couple of them then. That was, okay. I thought I did, but I wasn't sure. So, let's see. One of the applications of this is using something called the Pythagorean theorem, which is, really it's probably one of the most important things that come out of mathematics. In a practical sense, it's used a lot, okay? Not just by math guys, but by just people who are trying to do things. So, particularly if you're bracing, if you're trying to brace something up here, okay, and you need a right angle right there, then the Pythagorean theorem says that if you take these two lengths, okay, and you square them, then the two legs squared is equal to the sum of the slanted guy, or the side opposite the 90. Okay, so you remember this is a squared plus b squared equals c squared most likely, because you've actually had mathematics and you've seen that before. So this guy is called the hypotenuse. So the side that's opposite the 90 is called the hypotenuse. And A and B don't matter. You know, when I show this to high school kids, I always tell them, I say, well, A and B don't matter because they're just sides. It doesn't really matter which one you put first. But the C is big. You have to know that this one is opposite that 90-degree angle. That's your slanted one. Okay? So it's opposite your 90, so it's always got to go there. The other two don't matter. So if we have a triangle, a right triangle like this, and this is 3, and this is 6, and we're trying to figure out what this is. Okay, we'd use this guy on it. So 3 squared plus 6 squared equals c squared. Don't know what that is. So 9 plus 36, c squared. We're going to add those up. See here, we just square root because it's c squared. So we're going to square root everything. And you wouldn't use plus or minus in this case because you're talking about a length. And a length that obviously can't be negative. So you wouldn't, you'd throw it out. You'd say, okay, this is just square root of 45, which I don't know what that is. But in the Pythagorean theorem, see here they say express the answer in radical form, simplify if possible. But, you know, in a practical sense, you wouldn't do that. Okay? If you really needed to brace something so you were 3 feet here and 6 here, and you needed to know how far apart to spread those boards so that you got a right angle, square root of 45 isn't going to do you a whole heck of a lot of good. Okay? So, it does have, I mean, you know, I've used it just outside of work and school and stuff like that, just figuring things out. And some of you may have too, so maybe you know what. Let's do another one here. Change it up a little bit. I might have got a little excited on this one, man. 25. Okay, so here again, right? We got to know where that 16 is opposite that 30, or excuse me, opposite that 90. So it's got to go there. All right, and the A and the B, the 8. I don't know. I'm kind of giving this whole stupid thing away. I don't know what I'm thinking. So 8 is here. Okay, so that could be A or it could be B. It really doesn't make any difference. Okay, I put it up here, but it doesn't make any difference where you put it. You're going to get the same thing. So we have that. And then this one here, we're just going to work out 16 squared, I'm pretty sure it's 256. And then it's just a regular equation, right? I mean, you guys know that because you were showing me how to do them just a bit ago. 192. And then we would just square root that. $192.
13.856.
Okay. Or we can bounce. You said 856, right?
Yeah.
There we go. But the big thing is this one. Okay, the one that's opposite the 90, that's always C. We could have put 8 here, left this as A. It isn't going to make any difference. You're still going to do the same steps. Okay, so the A and the B don't really matter. But the 16, the C, does. Okay, so we got to make sure you... And in the book, the C's are always slanted. It's nice of them. Okay, they're not always going to be that way. But they're always slanted. Any questions on that? Okay, we get to skip 8.2. You wouldn't have liked that anyway. Okay, 8.3. So we're still solving quadratics. And I think what I'm going to do is I'm going to give you a big picture kind of little idea on this. So I'm going to switch from here to here. Maybe I think I will. Okay, so on this, all right, here's x squared plus a. So I just made it kind of a simple little quadratic here. We have this nice U shape, which is what they look like. Okay, called a parabola, which we get into Wednesday. All right, that's what they're going to look like. So if I move this around, I can see that obviously it's moving up and down kind of thing. All right, but here's what we want to focus on. So right here, okay, if I click here and click here, I'm pretty close. These are going to be the answers to my quadratic. Wherever I set it equal to 0, because that's what we're going to do is set them equal to 0, then this is going to be an answer. All right. So as I slide this down, okay, I'm always getting two answers. But if we think about it, one of them's got to be plus and one of them's got to be minus. Okay? So it makes sense that we'd have two answers because you're going to square root things. There is a situation where, right there, obviously where it's just touching the x-axis in only one spot. So there's a way we could just have one answer. And then here, I could slide this up, and it doesn't touch it at all. So we would only have, we don't have any real answers. So when we're doing these problems, okay, next, that's what you're going to see, is we're going to see that we could have no real answers, one real answer, or two. And I could make this even more complicated. I mean, we could throw a bx here plus c, or plus, yeah, I'll make it c instead. Get rid of the a, I don't need that one anymore. Okay, so this one here, it bounces all over the place. All right, and same with this. Okay. So we can get lots of different situations. See, there's no answers, and then there's that one point on here where we're going to get one answer. Here's two negatives, and then here's one over here. I don't know if we ever get two positives. Doesn't look like we do, but we could. Maybe if I extended those out a little bit more, okay, we could get a positive and a positive rather than two negatives here. Okay. Maybe if I just adjust it a little bit. Oh. There's positive and a positive, just barely anyway. There we go. There's a positive and a positive. Okay. So we get, either way, we're going to get two answers. We're either going to get one answer or we're going to get no answers when we're doing these. So I wanted to show that to you. Okay. So Desmos, again, is a nice little tool for finding answers to these. Okay, so solving quadratics. This technique works on every single one. And it's called the quadratic formula. And it goes like this. So if we're going to solve a quadratic, I'm going to write like this. Set it equal to 0. It's got to be set equal to 0. Then we can use this formula. X equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay? And they derived that crazy thing on page 550. If you are really interested in where does that come from, well, they'll show you right there. That's where it comes from. I'm not going to derive it because we need to complete the square, which is something that we don't even do. So, but here it is. Okay, that's the formula, and it works on all quadratics. That's what's great about it. Even those ones we just did, it'll work on those. Okay. The only thing is, it's got to be in this form, and it's got to be set equal to 0. Okay. You can't do it unless it's in that form and it's set equal to 0. So let's do an example, and then I want to show you at some point how you type that in Desmos too, so you can see how to use your calculator for it. Now you might remember, okay, that when we did these before, we factored them. And we used the zero product property. But the zero product property only works for very, very few of these. So it's not, I mean, it's okay if it can be factored, but if it can't be factored, then you can't use it. So like in this case, if we took this negative 20 and we said, oh, we're going to find factors, and I'm going to find one that works, okay? Problem is that this has to subtract to 9, and there isn't any more that subtract to 9. 1 and 20 doesn't, 2 and 10 doesn't, 4 and 5 don't. So you'd have said, I don't know how to do this. Hey, he never showed me this. It's prime, doesn't work. But the quadratic formula does work. So we just write this out. All right, so A is the number that's in front of, okay, that x squared term. All right, and B is the number that's there, and C is the number that's there. So A, I have 1x squared, I'm going to put a 1 there. B is 9, put a 9 there because I have 9. And C is a negative 20. All right, so now we're ready to use our formula. X equals negative B, so that'd be a negative 9, plus minus square root. And what I tell people to do is just, instead of taking this number and messing with it, just do it in right here. So go 9 squared, well that's 81, minus 4 times A times C all over 2 times 1. Four times 1 times 20. I know that's 80, and it's going to be a plus. And this is just 2, and then I just keep going. Now again, you're going to get, there's two different types of answers here. There's the decimal approximation answer, and there's the exact answer. So there's your exact answer. Negative 9 plus or minus the square root of 161. Can't do anything with that 161. Can't break it down. No perfect squares go in there. So you're done with it. All right? And that's your two answers, because you got a plus and you got a minus. All right? So if we graph this, right? If we graph it, let's see. I know probably one's going to be negative, one's going to be positive. I'm going to guess at it. Okay, so there would be one answer, and there would be the other. So if you took this in decimals, and right now, and you graphed this equation, okay, it's going to look like that, and your two answers are going to be this. Now, decimals isn't going to show you this square root thing, right? It's just going to give you a decimal approximation. So you would have to know that that's going to be a decimal approximation, okay? But that's how you use the formula. So let's try a couple more here, and then I'll get you out of here. So we'll break. So x equals, oops. Let's go with x squared minus 8x minus, here, let's do this one, 15 equals 0. Okay. A equals, B equals, C equals, so what's A? 1. What's B? Negative 8. Good. And C? Negative 15. Okay. So now we're going to use our formula. Okay, now we just got to plug numbers in. So opposite of B, so that's a negative 8, so I'm going to take the opposite of that. And now I'm going to square this. Now here's where you got to be careful, because I've seen this happen. All right, people will use a calculator, okay, and they'll go -8 and they'll square it. And what the calculator will do is we'll take 8 squared and then make it negative, and that messes up the whole thing. Okay, so that's why I always say just take that b squared and square it, because you're probably going to get it right more than the calculator will. It depends on the calculators, but most of the time that's what they do. So let's see, we got 4 times 1, 4 times 15, that's going to be 60, and so that would be 6124 divided by 2. 124 I think we can break down. I know 4 goes in there 31 times. So then we would square root the 4. That 2 is going to come out in front. 31 is going to stay inside. 2 is going to be there. Now, you think, aren't we done yet? No, because you can reduce this. 2 goes into 8, 4. 2 goes into 2 once. There's our exact answer. Okay. So when you're doing these, you have to kind of check that. You know, you'll see some in the book that you might be checking your answers and go, what the heck? But they can probably be reduced. And they're going to have, all of them are exact answers. Okay. Now for me, I don't really care if you give me an exact answer or a decimal answer. I'm not too worried about that. I'll take either one. I'm just, happy that you can use the formula and figure it out. So it doesn't matter. And I'll show you how to do it on Desmos when we come back. So take like a, this would be a great time to take a little 5-minute break. Slide your tests up here for me so I can get them back. And then we'll do a few more quadratics. We'll practice a couple. We don't have a quiz today, so we'll be done. Okay, so I was looking at some of this stuff over here. Let's take a look at, so I'm going to bounce a little bit back and forth between these two, the tablet and the computer, so prepare for that. Alright, let's try, let's just do one like this. This time we'll throw an A out in front. Okay, so here we use quadratic formula. Alright, then I'm going to graph this so I can show you how the two answers are, and then I'm going to show you how to do it on Desmos too. So here's our problem. 3x squared plus 5x minus 9 equals 0. What's A? 3. B.
5.
And C. -9. Here we go. X equals opposite of B. -5, plus or minus. Square root, b squared, what's that? 25 minus 4 times 3 times -9. Okay. Now understand, I'm writing a lot of this stuff out. Okay. So if you've got 20 problems to do, I don't know how much you're going to want to write out. Okay, that's up to you. Okay. What's going to be on the bottom? Good. Okay, so -5, plus or minus. What are we going to get inside this thing? What do we got here? We got 4 times 3 times 9, 108, and then we got to add that because this is a plus and a plus. So is that 133 then? 4 times 3 is 12, 108. 108. 133, yep. Okay. I can't do anything with the 133. Alright? So I have negative 5 plus or minus square root of 133 over 6. That's it. Okay? Can't do anything more with it. Alright? So if I go to graph this, okay, so I'm going to go bounce, so I'll come back. Alright? And we go into here. I think I still have decimals up there. It is. Going to get rid of this guy, and I don't need this, and I don't need this. Okay, so I type this in, 3x squared plus 5x minus 9. Okay, so that's what it looks like. So our answers are here and here. Okay, well, no way does that look anything like what I got. Okay, but if I go to the second line and I type this negative 5, so I'm going to go negative 5 plus, now I should back up here a little bit. We need to put a parentheses first. So negative 5, okay, plus square root, I'm just going to do the whole thing here, 25 minus 4 times 3 times negative 4, okay, click outside the parentheses, divided by, see how it puts the whole thing, oh sorry, negative 9, thanks. I don't know why I thought it was 4, there we go, 9, divided by 6, okay, 1.08, well that's the same guy that I had here, okay, so that's the same answer as this one. Yeah, maybe do this so you can see it better. Okay? So that's the same answer. Alright? This answer is the same as this one. Now, if I do the exact same thing, I'm just going to click up here, but I don't need the plus anymore. I want the minus. Now it changes to negative 2.7, which is that one right there. Okay? So, that's what's happening. Alright? I took this, I put it in here. Okay, notice that you want to square that 25. Okay, I'm not exactly sure how Desmos handles that. If you put like if it was a negative, maybe we'll check it out and see. But that's how you enter it. Okay, and it's just a quick click there, tap there, whatever. In your case, change it to a plus, change it to a minus, whatever you have, and it will give you those two answers. And it should go with these. Okay, so one of the questions that's going to be on your test or quiz is going to be solve these quadratics, verify your answers using a graph. So then I would expect that you would type this guy, you would graph it, use the quadratic formula, and then, hey, I'm going to check my answers. And if my answers here don't go along with the answers that I'm getting on paper, or what I'm getting here, then I know I made a mistake someplace, particularly if you're checking it on paper. Okay, and I know, man, I must have messed up. So I got to go back and figure out what it is. Okay, it's the same thing we did when we were solving those linear equations. Use a graph to help you out. Okay, so let's go back to, sorry, I'm bouncing back and forth here. So let's go into this. And let's look at a different one. Okay, so let's look at one like this now. Same thing, all right? This time we're going to go with x squared, okay, minus 8x plus 16 equals 0. So now we're going to have one like this. Okay, so let's go A equals, B equals, and C equals. So what's A equal in this case? 1, B is negative 8, and C is 16. So let's see what happens. All right, so we're going to put this guy in. All right, so what am I going to put first here?
8.
8, good. Plus or minus square root. What's going to go in the first spot?
64.
64, good, because we're squaring that 8. Okay. Minus 4 times, what do we got here? 1 and 16. All over 2. Okay, good. So we have 8 plus or minus square root 64. Now, what am I getting right here? What does that give us? 4 times 1 times 16 is 64. And like somebody's telling me, hey, that's 0. Yep, you're right. Square root of 0 is definitely 0. Okay? So how do I handle that? Well, I don't have to worry about the plus or minus because I'm not adding or subtracting anything. So I just take 8 and divide it by 2, and we get 4. So there's our one situation where we're getting 4. But remember, I said that big picture was in those quadratics when we were sliding them around. There's a chance where you could just get one answer. All right? And that's what you get. Okay, so if I bounce back into here, okay, and go into this, and let me get rid of this and get rid of this, type this in, x squared minus 8x plus 16. Okay, look at that right there. See, there's your 4. All right, so it works. It's justified. There's our 4. So up here, we got 2 answers. Ugly, looks ugly from right here, okay? But there were a couple decimals. This would be one answer, okay? Touches the x-axis once. All right, so let's try one like this. Let's go with a 3x squared plus 7x plus 8 equals 0. So what's A? 3. And B? And C? 8. There we go. X equals. What am I going to put here in the beginning? Negative 7. Good. Maybe I'm going to put negative 7. Come on. I'm trying. Negative 7 plus or minus square root 49. Good. Minus 4 times. What's going to go there? 3. And here? C. 8. Good. Okay. And what are we going to divide it by? 6. All right. Okay. 4 times 3 times 8. What do we get there? 12 times 8. 96. X equals negative 7 plus or minus square root. Now we got to take 49 minus 96. So that would be a negative, how much? Nan's working on it now. She's got 47, okay. All over 6. Uh-oh, we have a negative underneath there. Well, and we know that from previous, and we can't have that. We can't take the square root of a negative number. So this doesn't have a real solution. Okay, so if, and we will here in a second, if we jump into Desmos and graph this, then what's going to happen to that graph? What's it going to look like? What do we got? Yeah, it's not gonna work. So, oops, I don't know why I did that. It's not gonna cross the x-axis. So let's give it a shot. Type it in here just to show it. So we got 3x squared plus 7x plus 8. Okay, there it is. It doesn't cross the x-axis. It's way the heck up here. Okay, so we don't have any real solution. All right, so there's the third example of where it doesn't work. Okay, so if you get something like that, you go, oh, yeah, my answer is check because I had a negative in the square root. It doesn't cross the x-axis, so I'm good to go. Okay, so you're going to get 3 possibilities. And if we type it in here, I should have typed in that other one, but I didn't. Rats. So I'll start with this one. Negative 7 plus square root. Okay, I'm going to go 49 minus 4 times 3 times 8. Okay, outside of it. See, right away, you saw says undefined, okay, because it doesn't know how to do the square root of a negative number. Okay, so that's no real solution.
In reality, wouldn't it be an imaginary number if you were doing that?
It would be, and that's on Wednesday. Okay, yeah, it would be, you're right. So when you're doing these problems, again, I don't care whether you, if you want to figure out that use decimals to come up with decimals, that's okay. All right, but they're going to have you do them in this type of form where you get this exact answer. Okay, so when you're checking them in the back of the book, that's what it's going to show you. I'm just going to tell you straight up. All right. For me, purposely, I really don't care which ones they are. All right. On a test or a quiz, it doesn't make any difference to me.
Care if we use decimals for these?
I don't care that you do. All right. But when you check your answers, they're not going to work. Okay. Let's go with. You're going to see something like this. We only got a few more minutes here, pen. Keep holding in. All right. Like this. Okay, where that's going to be there. All right. It's not equal to 0, so you got to swing it over. And set it equal to 0. Okay? And then you just go ahead and do it. So you have to be real careful making sure that you're getting it in the right form. Alright? There's some more. They're going to look like this. I'm just looking at these that are in here right now. Some that are like this. Okay? On these, you can use the quadratic formula, all right, but I don't know why you would, because what should we use on this one to get the answer? Just square root it. Just square root it. Okay. But you can use the quadratic formula. You'd have to do some foiling to get it there. Okay. All right, so that looks like that. 16 square root of 16 is 4, so I got a plus or minus here. Now we're going to subtract 1. 2x equals, now I'm going to get a negative 5, or 2x equals 3. Do you see how both those answers are coming out? So this is a plus or minus 4. So minus 4 is going to give us a minus 1, gives us a minus 5. Plus 4 minus 1 gives us a 3. And then divide by 2, and that would be our two answers. Do you see how that one worked out? Okay. So you might have something like that. So if you see something like that, I would just square root them and not bother with the quadratic formula. Okay? Just square root them. But you got to set them equal to 0. Okay? And they'll throw some at you that aren't. Any questions on that? None? We're good? Okay. I got nothing then.